Whew. All right, now in the last video, we went over what a flux is and the angle potential that we might have and the equation for it and the unit for it. Now let's talk about flux in terms of, earlier Billy said flux means change. That's correct, Billy. You are right. Let's talk about that. When we have a current carrying wire in a magnetic field, we all remember what Michael Faraday discovered. Well, let's go back to Ørsted. Ørsted said, he had a current carrying wire produce a magnetic field, and Faraday found out the opposite. He found out that a magnetic field can induce a current in a wire. However, here's the catch, okay? We haven't talked about the catch yet. We just mentioned that is true. Now we're going to go into some of that stuff in detail because that's the important thing, kids. When you have a magnetic field and you have a wire that's moving or rotating or something's changing, hence flux, that's where you get an induced current. So it's not just you have a wire in a field. The wire's got to be doing something in the field. It's got to be moving. The field's got to be changing direction. It's got to be doing something relative to the field, or the field can actually be moving relative to the wire. So you could have a magnetic field that is like rotating and changing with just a stationary wire, and that'll cause current in the wire. So what we have to have, and this is really a little bit more of an extenuation of what Faraday discovered, is that in order to get a current in a wire, you have to put it in a changing flux situation with a magnetic field. All right, now what are you talking about? There's a lot of different ways that we can get a current to be induced. That's called induced EMF. Induced EMF. Let me write that down for you. Induced means forced, made to do something, forced to do something. Induced EMF, which stands for, it's an old way of saying electromotive force, an old way of saying voltage. So what you're going to do is cause a voltage, or this voltage can cause particles in the wire to move, so you can get a current moving in the wire. So that's why it's still called EMF. Something forced it to do that. Yeah, okay, yeah, but that's also voltage. So you remember all the different words that we have for voltage. You talk about EMF, you talk about voltage, potential difference, electric potential. All those things meant voltage. And so this is induced voltage on a wire. In other words, making current move through the wire. Now, there's a number of ways we can do that, but you got to have something changing. Hence the word flux that Billy talked about. Something has to change. What do you mean? What are you talking about? Give me an example. Okay, here's an example. Let's say I've got this wire. Sorry. And I've got a magnetic field. Maybe there's over here I'll draw this up here on the board for you. So let's see, we'll draw here a magnet with the North Pole here and a magnet with the South Pole here, and there would be a field, remember, out of the north into the south. So we would have a nice magnetic field going from the north to the south here like this. All right. Okay. All right. Now there's a magnetic field produced. Now if I have a wire just sitting here in the field, I will get nothing happening. In fact, you have to have some kind of a changing situation in order to get a current produced in the wire. Remember, it kind of goes back to when we talked about the particles. In order to get a force on a particle, the particle's got to move. Because remember the equation for magnetic force on a particle? It's V, B, Q, V, V. It's got to be moving. If it ain't moving, there ain't no force. Okay, so you got to have something moving. So we can take our wire and we could move it through this field like this. And if I move it through the field, actually what I'm going to do is right now, how much flux would there be for the field right now? Zero. It'd be zero flux, right? Zero flux is we don't have any lines going through it. Let's make maximum flux. Ooh, look what I just did. So, see, you're going to love this thing. I'm telling you, this is the best teaching tool ever. Okay. So right now, I've got field lines going through, and I have some flux. I got flux. So if I change the flux, I will induce a current in this wire. How could I change the flux? Well, I could take this wire and I can move it out of the field That's changing the field, which will cause the current to move in the wire. I can move it back up through the field. What's happening? The flux is changing. There's no flux down here. There's no wire, no lines going through the wire. So if I move it up through, I know I'm increasing the flux as it moves up through, changing the flux. It's kind of redundant, isn't it? Changing flux. Okay, it's funny if you think about it, because flux means change. If I change the flux, then I will cause a current to be induced in the wire. So that would change the flux. Pulling it out would change the flux. This is not going to change the flux, huh? Can you see why? So right now, I'm not changing the flux of the wire. It's maintaining the same. I'm moving the wire, but the flux isn't changing. It's not the flux changing. So how else could I change the flux? What else could I do? Ooh, check this out. Rotate the wire, because how much flux do I have now? 0. How much now? Maximum flux. How much now? 0. How much now? Maximum flux. See, rotating the wire, which becomes muy importante, grande, because that's how it's done, people. Seabrook, so we get our power, but that's where it's done. They rotate the wire. Okay, we'll talk about that very soon. That's the way it's done. But there are other ways to change the flux. Again, doing this would change the flux. Well, actually, there's no flux there. Go back to this. Doing this would change the flux. Okay, change the flux that way. The other way I could also change the flux by remember, flux means the amount of magnetic field lines going through an area, is I could shut the magnet off and on, or maybe rotate the magnet. I could rotate the magnet, and that would cause a flux change. So you could hold the wire in place. Instead of moving the wire, you can hold the wire in place, and you can move the magnets in and out of the area where the lines would be going through, changing the flux, or you can move them back and forth. Okay, moving them back would weaken the magnetic field. Moving them closer to strengthen it. So you can move the magnets back and forth. Okay, you can move them up and down, changing the angle and the amount of flux. So there's many different ways you can change the flux. It doesn't have to be the wire moving. You can move the magnets as well. Okay, that's usually not the way it's done. Like at a power plant, that's not very convenient to move the magnets. You keep the magnets because these are big magnets at a power plant, and you move the wire. That's the easy way to do it. And we'll talk about that once again in just a minute. Okay, one more way I can do it, one more way, is that we can leave the magnets here, have a nice magnetic field here, like we said, going from left to right, and I can change the area of the wire. Oh, how can you do that? Oh, look at that. You're magic. Magic. Yeah, what did I just do? I changed the area. I made it a smaller area and larger area. And if I do that with the field lines, smaller area or larger area, well, if I make the area smaller, there's not as many lines going through. So the flux equation, you remember, flux, V phi pho fum, is B times A. So if I'm changing the area that the magnetic field is going through, then I'm going to change the flux. And that, too, can induce a current to move through the wire. Again, that's not a convenient way of doing it. Like at a power plant, you don't have somebody sitting there going, okay, I'll just change this. Okay, that's going to make some nice electricity for everybody to turn the lights on and off. No, not very convenient way of doing it. So that is not, but it is a way of doing it, not the way it's done. The way it's done at a power plant, it's done by rotating the wire through a established magnetic field. All right? Okay, so in order to get a current, once again, a quick review, to get a current, you have to change the flux. You can change the flux by changing or moving the magnetic field. Not very convenient for the most part. You can do this by moving a wire in and out of a field. Okay, that's one way of doing it, changing the area of the wire or rotating the wire. We're going to find out next video. That's the one of choice, kids. So, okay, here we go. Next video coming up.